Okay, so that's what we were doing last week. If you're just finding the probability that one thing or another happens, you really just add the two together. So the probability of green or blue, if I just add those, it'll be 9 out of 12, which is 0.75. Then, if you're finding the probability that two things happen, so you draw a marble without replacement, which means it is dependent because you're changing what's in the bag. You find the first probability, so the probability that it's green, which would be 4 out of 12. And then you multiply it by the second probability. So we took away one of the green ones. So the probability that the second marble is yellow is 3 out of 11. And then I multiply those together. Do what? Yes, which would be 0.09. So there's about a 9% chance of that happening. Huzzah. Okay, so today we will talk about conditional probability. So that is basically just a formula. And it looks like this. Hold on. Okay. And I wrote it on the board too. But the way that that is said is the probability of B given A, meaning what's the probability that whatever B is going to happen, given the fact that we already know that A happened. So like something happened, what's the probability that the other thing will also happen?
At like the same time?
Or like after it, or it could be the same, like we know that this is going to happen, so what's the probability that this other thing will also happen? Yeah. The main thing is just you want to make sure you know what A and B are, so you can put stuff together. So if it says the word given, find that, and B will be before the word given, and A will be after the word given. If it doesn't say the word given, I usually recommend that you like rewrite whatever the statement is using the word given, just so that you make sure. Like A is always what we know happened, and B is what we're figuring out what's the chances of it. So in this case, A would be a teenager owning a skateboard, and B would be them owning rollerblades, which I don't know if rollerblades are still lame, but when I was in middle school, I had rollerblades and I found them very fun.
My mom said she used to go outside the school.
And we're like in middle school, it was cool. In high school, it was not. But looking back, it's like, man, that was so fun to ride around in rollerblades. All the good old days when I was 13 and 12 or whatever. Anyway, so this one it gives you the probabilities. So the probability of someone owning a skateboard, which would be the probability of A, is going to be 0.48. A and B, so skateboard and rollerblades, is 0.39. So the probability of B given A is just dividing those two. 0.39 divided by 0.48, 0.8125. So if we know somebody has a skateboard, there's about an 81% chance that they probably also have rollerblades, meaning they were super cool. Just so you know. Okay, so this one. It's funny. I had to write the question over here because I forgot to I accidentally cut it off when I was making it. That's why that's just written over there. But sometimes they don't give you the probabilities like that you actually need, the two that you need for the formula. So the best way to figure it out is with a tree diagram. So there's an airport screener, bag screener for forbidden items. And the alarm is supposed to go off when a forbidden item is detected. So we know that about 5% of bags contain forbidden items. So on the first branches, we're going to start with forbidden and then not forbidden. So basically, every time you make like 2 branches, it's like something happening or it's not happening. Because the 2 branches should always add up to 1. So we know that this one is 0.05. So this one will be 0.95. Because if 5% are forbidden, 95% won't have anything forbidden. It doesn't look like 95. Let me fix that. 0.95. Okay. So then they tell us that if a bag contains a forbidden item, there is a 98% chance that it triggers the alarm. So we have alarm, 98% chance, and then no alarm would be a 0.02. Does that make sense where I got 0.02? Cool. If there is no forbidden item, the alarm is 0.08, and no alarm would be 0.92. So remember how like when you find in the first problem, you're finding the probability of 2 things happening, you multiply them. So for the and stuff, like forbidden and alarm, you would multiply 0.05 times 0.98. So this would be the probability that it is both is 0.049. 0.05 times 0.02 is 0.01, or sorry, 001, which they both add up to the 0.05, if you'll notice. And then 0.95 times 0.08 is 0.076. 0.95 times 0.92 is 0.874, which if you add those 2 up, you get the 0.95. So all of it has been accounted for. Anyway, if you add all 4 of those up, it would be 100%. So we want to know the probability. Okay, so here, let me read it the way the problem says it. The alarm goes off. So what is the probability that there is a forbidden item? So that's where I say like it kind of helps to rewrite it. So forbidden, it'd be forbidden given, or here I'll just write the word given that the alarm went off. Okay. So probability of forbidden given alarm. So we need the probability that the alarm goes off and the probability of forbidden and alarm. That's what we need for our formula. So forbidden and alarm we found, 0.049. So the probability that the alarm is going to go off. Well, there's 2 situations in which the alarm would go off. Either there's a forbidden item and it goes off, or there is not a forbidden item and it goes off. So that is going to be the 0.076 plus the 0.049. Does that make sense? Because those are the only 2 situations where the alarm would go off. Forbidden and it does, or not forbidden and it does. So 0.049 plus 0.076, which is 0.125. Yeah. So then we just divide. 0.049 divided by 0.125 0.396. So if the alarm goes off, there is a 39% chance that there will be forbidden items in there. And the reason why it's not higher is because it's such a small percentage of people that even have forbidden items, if that makes sense. Because 95% of people don't. So, but so I would say that's pretty good. That's pretty good odds. You know, if you're trying to catch them. Anyway, so the first few are just the word problems where they give you the exact ones that you need. And then there's a couple of the tree diagram ones. The next one, the one on here is like testing for a certain disease. Positive, negative, whatever.